So I've been doing some work on the Artemis board today. So I pulled all the caps off because A, they're mostly fried, and B, it sure does make it difficult when the board weighs a ton and you're trying to do a bit of reverse engineering because it's covered in caps. So those are going to have to come off anyway. I've still got to take some of the fry components off, but I'm going to go sit down and order a ton of parts. But anyway, before I started commencing work on it, I wanted to sketch the schematic out and just see what it is. So anyway, yeah. So input stage, there's two power supplies on this. There's the main one for the output stage, the 26S33S Russian triodes. There's an AC heater supply, and there's a small high voltage supply for the driver stage and input stage. So drive stage comes in, bit of filtering, your standard sort of couple of resistor capacitor networks. So the audio input signal comes through here. There's an interesting little bypass cap, quite low value across the cathode of this, which you can actually remove a link from. Don't know why, but it's there. It isn't on the second valve. So the input stage is also the phase inverter. So you've got your standard anode resistive loading on both these valve stages. However, there's a adjustable network in between the two. So the output from this one is actually feeding into this valve. That's what gives you, is this one swinging positive, it'll drive this valve on more, it'll swing negative. So you adjust this to try and get some even balance out of the two. However, I'd be more inclined to actually do it post drives, because at the end of the day it's the output valves you want the even drive on. But if this is even, the next stage should be pretty even. So that's the input stage, also phase splitter, that's 12AX7. That then couples from two capacitors to the driver stage. Driver stage is very simple, it's just two identical stages, receives their signal from the input stage, goes out to drive the output valves. The output valves themselves I've not bothered drawing because it's just transformer connections on them. The output stage, so there's no feedback, negative feedback from the actual speaker output to the amplifier input. There is, however, cathode feedback. So the output transformer has two windings for the anode load on the two valves in push-pull. But then it has two feedback windings which get put in the cathode. The cathode bias resistors, the feedback windings connect to that and then head off to the cathode of the valves. That's where the anode of the valves comes from, and the grid of the valves is just driven from this. The bias network, oh yeah, there's several powers, there's four actually. There's the power supply for the output stage, the power supply for the driver stages, the heater supply, and then there's the bias supply. So it's just got a small bridge rectifier, couple of smoothing caps. Remember, because the positive of the bias supply connects to 0V, you actually want the filtering in the negative. So there's an RC filter here. Goes off to some potentiometers. One end of them goes to the 0V rail through high resistance, and the other end goes off to the grids of the output valves, and they then sit as two potentiometers that stick out the side of the amp. You can adjust, and there's a socket at the back. Yeah, and then the power supply. This took me a bit figuring out because I'm looking. I just got it in my head. There was some weird transformer. I couldn't figure out what this second. So you got the main input cap bank, and then there was this cap bank here. And the only connection it had on the board was what appeared to be through a transformer. That one leg connected, well, like here and the other to there. But one leg seemed to connect to the positive of this, and then seemed to connect to the positive of this one. And I just could not figure it out until I was doing measurements on the output transformers and voltage measurements on the power transformers, and finally realised it's actually just a big toroidal choke. It's not a transformer at all. So yeah, there's a multi-stage choke supply, so there's four capacitors. When I took this apart, it just had the one in here, but I'm going to put four lower value ones in. Big ass choke, and then there's for some reason they then went with stacked lower voltage capacitors with bleeder and balance resistors on them. I don't know why. Don't know why they didn't just use a couple of, they put room on here for lows. They could have put a couple on here and then saved themselves space by putting half as many caps on there. meh. Strange, you know what I mean? You put 2 caps in series as well. So these are 4,700 microfarads. So each one's only like 2,300 mics. Still a lot of capacitance for a valve amp, but I don't know. And then they went and left them out, but who knows? Anyway, doesn't matter. I'm recapping it. Going to put more in there. Yeah, bias filters. These are all the various bias filters and HT filters and stuff. I think I've drawn them out. I might have missed them out somewhere. But anyway, yeah, the amp itself, the actual working schematic, it's pretty simple. As you can see, there's not a lot to it. So, yeah, anyway, that's what I've spent the last few hours doing. I just thought someone might find that interesting. So, as always, thanks for watching.